Here's another polar coordinates integration example. Integrate f of xy is x squared plus y squared to the negative 2 power. So the exponent there is negative 2. I know it might be a little bit hard to read. Over the region D, where D is this region right here. What's going on in this picture? Here is a circle of radius 1 centered at the point 1 comma 0. And it's the top right quarter of a circle right there. Okay, so we want to figure out what's going on here. Polar coordinates is going to be a great choice here. If for no other reason, note that we have this x squared plus y squared to the negative 2 power. So when we switch to polar coordinates, that's going to be r squared to the negative 2nd power, which is r to the negative 4th. So that will be nice for us. Describing this region right here, a couple things to go here is that you should know, I think this was discussed in a previous section, but if you go all the way back to Calculus 2 and polar coordinates, the equation of this circle of radius 1 centered at a point 1 comma 0, this circle has equation r is equal to 2 times cosine theta. This is, as I said, radius 1 centered at the point 1 comma 0. If you don't believe me, let's write down, this is, if I asked you to write down formula equation for a circle of radius 1 centered at the point 1 comma 0, I think this is probably what you'd write down. If we expand this out, okay, that give us x squared minus 2x plus 1 plus y squared is equal to 1. And now we convert to polar coordinates. Well, x squared plus y squared, that's r squared. And those 1's cancel. And in polar coordinates, r squared, x is r cosine theta. R squared minus 2r cosine theta is equal to 0. Factor out an r, and we get r times r minus 2 cosine theta is equal to 0. And this right here is exactly r is equal to 2 cosine theta. Okay, so this circle is r is equal to 2 cosine theta. We should also realize, what else do we have to do here? This line right here is x is equal to 1. But if x is equal to 1, that's, well, x is, remember, we just said, x is r cosine theta. Solving for r in terms of theta is r is equal to 1 over cosine theta, or r is equal to secant theta. Okay, so we've got that expressed in terms of r and theta. And I think at this point, we should be able to write down our bounds on theta and r. So theta is equal to 0. We start, we end right here at that theta value. This is the 0.11, which has theta is pi over 4. So theta runs from 0 to pi over 4. As for r, let's see here. For a generic theta value, the smallest r can be is this line, corresponds to this line right here, which is r is 1 over cosine theta. And the biggest r can be is at this circle right here, which is, we said, r is 2 cosine theta. So our integral, theta runs from 0 to pi over 4. R is 1 over cosine theta to 2 cosine theta. We said that our integrand is r to the negative 4th power times, don't forget the r dr d theta. Okay, so this is going to be, theta runs from 0 to pi over 4. Let me just save a step here to say that multiplies together as r to the negative 3rd power. And antiderivative r to the negative third power is r to the negative second power divided by negative 2. Plug in r is 1 over cosine theta to 2 cosine theta d theta. And we end up with, let's see here, that negative 2 in the dark can be moved outside. And, okay, plug in 2 cosine theta. We get into r to the negative second power. That's 1/4 secant squared theta. And then plug in 1 over cosine theta into r to the negative second power. We get cosine squared theta d theta. Okay, one variable integration should be pretty straightforward for us. Of course, the antiderivative of secant squared theta is tangent theta, so that will be nice. As for cosine squared theta, we just need to replace cosine squared theta with 1 plus cosine of 2 theta over 2. This will allow us to perform the integration. Okay, so negative 1/2 times, said here, antiderivative of this would be tangent theta. The antiderivative of this, let's see, negative 1/2 times. Antiderivative of 1 would be theta. Antiderivative cosine of 2 theta would be 1/2 sine of 2 theta. And plug in theta from 0 to pi over 4. And so this would leave us with what? Theta is pi over 4, negative 1/2 times 1/4. Tangent of pi over 4 is 1, minus 1/2 times pi over 4 plus 1/2 times sine of 2 times pi over 4, sine of pi over 2 would be 1. Okay. And then now when we plug in theta is equal to 0, all of those terms end up as 0. So simplify that, and that's your final answer.